Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we're going to continue our conversation about half-angle identities in trigonometry, and we're going to focus quite a bit on just finding the exact value of weird angles that we've never been able to evaluate before, like in this case, the tangent of 15 degrees. And that's why this is called evaluating trigonometric functions of non-special angles using the half-angle identities. So, how do you do this? Well, if somebody said I need to find the tangent of 15 degrees by hand, I would have to either use a sum or difference formula or a half-angle identity. Basically, I'm asking myself, how can I get to 15 degrees using special angles? Well, there are a couple ways. One way you can do it is you could say 15 degrees is the same thing as 60 minus 45 degrees. Those are both special angles. And so I can say, oh, that's a tangent of 60 degrees minus 45 degrees. And then I can use a difference formula for the tangent. However, another way you could do it, and I think somewhat easier way of doing it, is to note that 15 degrees is just half of 30, and 30 is a special angle. So really your goal is to find the trig function of a special angle, I'll write it that way, over 2. You want that angle to be a special angle over 2, if you can do that. It involves a lot less critical thinking when you do it that way, versus what two angles do I have to add or subtract to get to 15 degrees? I think it's just much easier to say 15 is half of 30, and 30 is a special angle. So in this case, we have the tangent of 30 degrees over 2. That's a half angle formula. And so I'm going to go back because as I mentioned in the previous video on the theorem involving the half angle identities, I did say I don't have my students memorize the half angle formula for the tangent, and therefore I don't memorize the half angle formula for the tangent. I don't have a need to, but the half angle formulas for the sine and cosine, I definitely remember. The half angle formula for the tangent, though, is either 1 minus cosine of the angle over sine of the angle, or sine of the angle over 1 plus cosine of the angle. It doesn't really matter which one you use. I'll use the first one, 1 minus cosine of alpha over sine of alpha. So here we have it, 1 minus cosine of the regular angle, the easy angle, over sine of that easy angle. Now again, this is not a memorizable formula. I do not think students should memorize the half angle formula for the tangent. Also notice here, the tangent is the one half angle formula that does not have a plus or minus in front of it. And there's a special reason for that. It is because tangent has a period of pi, or 180 degrees. And so when you take half of its angle, it just reduces essentially into the two quadrants previously. So if it was positive, it still remains positive. It doesn't really matter. The fact is you don't have to worry about the plus or minus there. So let's go ahead and draw out our special triangles, or our one special triangle actually that we need for this, which I butchered a little bit there. Sorry about that. The 30, 60, 90, 1, 2, root 3. And we can see the cosine of 30 degrees is root 3 over 2, and the sine of 30 degrees is a half. So let's go ahead and do this. This is going to equal 1 minus the square root of 3 over 2 divided by 1/2. Now I will just multiply both numerator and denominator by 2. And when you do that, you'll get 2 minus root 3 over 1, or in other words, just 2 minus root 3. Notice I'm able to find the tangent of a non-special angle. Tangent of 15 degrees is what we just found. Tangent of 15 degrees. We did that without using a calculator. So it turns out our special angles, 30, 60, 90, 45, they end up allowing us to evaluate more than just trig functions at those special angles. We can now evaluate trig functions at half of those angles, or at sums or differences of those angles. So we start really getting a larger collection of trig functions and angles we can evaluate trig functions at. Let's try another example here. Find the exact value of the cosine of 7 pi over 8. Now let's suppose that this was on an exam or something like that, and you did not know what formula to use. Okay, so you're just kind of floundering a little bit. You're saying like, gosh, I don't know what this is, and you're not allowed a calculator. So you're just staring at this. You're looking at it going, I don't know what to do, because this is not a special angle. 7 pi over 8, its reference angle is pi over 8. That's not a special angle. So what do? Well, you should ask yourself, is that half of an angle or twice of an angle that you know? So that's what I wrote here. Is 7 pi over 8 half of some special angle or twice a special angle? And a better way to write that, because you don't want to use words the entire time in mathematics, you could rewrite that as, is 7 pi over 8 1 half of, let's just call it x, actually let's call it theta. Or is 7 pi over 8 twice a very special angle? Well, let's do with the twice very special for a moment here. Let's just divide both sides of that by 2. That would imply we're looking at 7 pi over 16. And sorry to say, but that is definitely not a special angle. You can easily see there's no way to reduce that fraction. And the reference angle there is a pi over 16. It's just, actually, it's not even a pi over 16, but it's not a special angle. There's just nothing I can do with that. So that's not going to work for me. That's not a special angle. So let me go ahead and go to the top one. Let me multiply both sides by 2 and see what happens. If I multiply both sides by 2, I get 7 pi over 4, actually. And that has a reference angle that's special. That is a very special angle. 7 pi over 4 has a reference angle of pi over 4, and that is one of our very nice angles. So I'm going to go ahead and say that yes, cosine of 7 pi over 8 is definitely cosine of a very special angle, 7 pi over 4 divided by 2. Notice I found the angle first. I just said, what is it the half angle of? 7 pi over 8 is half of what? Oh, it's half of 7 pi over 4. So I rewrote 7 pi over 8 as 7 pi over 4 divided by 2. And this allows me to use the half angle identity. The half angle identity for the cosine is a plus or a minus, and I wrote that in blue on purpose, the square root of 1 plus the cosine of that angle, that special angle, divided by 2. And remember that 2 is on the inside of the radical. So now look at what I'm working with. I'm no longer working with the cosine of 7 pi over 8. I'm working with the cosine of 7 pi over 4, which is a much easier angle for us to work with because the reference angle is pi over 4. Now, before I continue, I want to make a quick mention. You cannot have two answers from this. There will only, the cosine of 7 pi over 8 is not plus something or minus something. It is one number. It is not two. It's not the positive number and the negative number. It's only one answer. So we need to ask ourselves, is the cosine of 7 pi over 8 positive or negative? And the only way you're going to find that out is by looking at what quadrant 7 pi over 8 terminates in. So here is our Cartesian coordinate system. Remember, pi is the same thing as 8 pi over 8. So if you open up an angle to 7 pi over 8, you're in quadrant 2. And we know that in quadrant 2, cosine is, I'm going to put quadrant 2 here. We know that in quadrant 2, cosine should be negative. So we are going to throw out the positive version, because in quadrant 2, again, cosine should be negative. So that's how you do this. You start by, if it's not an angle that you know how to take the cosine of, you start by asking yourself, is that half or twice an angle? So I just asked, is it half an angle? It is. It's half a special angle of 7 pi over 4. Great. So I just wrote that out. That's a cosine of 7 pi over 4 divided by 2. Then I used the half angle formula, plus or minus the square root of 1 plus the cosine of 7 pi over 4. That's all being divided by 2. And then before I continued forward, just so that I didn't make the mistake of carrying that plus or minus through, before I continued forward, I asked myself, wait, is it plus or is it minus? Look at that quadrant. 7 pi over 8 is in quadrant 2, and cosine will be negative. So my answer needs to be negative, so I throw out the positive. The rest of this is just straight computation. So we have now that this is equal to a negative square root of 1 plus something over 2. Well, let's take a look at this. What is the reference angle for 7 pi over 4? The reference angle there is pi over 4. So cosine of 7 pi over 4 is almost like a cosine of regular old pi over 4, but you have to take into account what quadrant 7 pi over 4 is in, and we know that's in quadrant 4, which means that this will be a positive cosine of 7 pi over 4, because cosine is positive in quadrant 4. So there, my mantra is that trigonometry is all about reference angles and quadrants. In this problem so far, we use quadrants twice. We started with this cosine of 7 pi over 8. 7 pi over 8 is in quadrant 2, which tells me that cosine will be negative. We then found out that, oh yeah, 7 pi over 8 is half of 7 pi over 4. And we use the half angle formula. We get to this point and we say, okay, I want to exchange out that cosine of 7 pi over 4 for the cosine of its reference angle, but I need to consider the quadrant. And so the reference angle is pi over 4. The quadrant is 4 for 7 pi over 4. And cosine is positive in quadrant 4. And now I finish evaluating this by saying this is the negative square root of 1 plus 1 over root 2, all being divided by 2. Now in this case, you do have to simplify this because that's a, within this radical, that is a compound fraction. So I'm going to multiply both numerator and denominator inside this radical by the square root of 2. When you do that, you get a negative square root of root 2 plus 1 over 2 root 2. Now, as I have repeatedly said to my students, you can go ahead and leave your answer like this. However, some instructors in some courses might say, I would like you to rationalize that denominator. Well, this is kind of tricky because this one specifically can be rationalized very nicely, but I would be okay with this answer. But in blue, I'm going to write out how to rationalize this denominator if you wanted to. So the next piece is optional for my students, but maybe not for your class. So let's say that you move on to the optional piece and you say, oh, my instructor requires me to rationalize denominators. Great. Okay, fine. I'm going to multiply both top and bottom by the square root of 2. And that's inside the radical. And this would give me a negative square root of 2 plus root 2. Well, the numerator didn't get any cleaner, did it? However, the denominator does, because you have 2 times root 2, which is 2 times 2, which is 4. And you can actually take the square root of 4. So this would be in a negative square root of 2 plus root 2 over the square root of 4, which is 2. So technically that could have been simplified to that point. But if you look at the blue ink here and the black ink there, they're the same number. So I don't really care. My students, just letting you know, I don't care. That's not that big of a deal to make that change. All right. Now, these are the only two examples I had for this, but I think that this is such an important concept that I'd like to do just one more example. I'm just going to make one up, which is always a dangerous thing. Example. Let's take a look at, let's do a sine of a half angle, okay? So let's consider the sine of 157.5. Now, you might look at that and say, I have no clue how to do a sine of 157.5. That looks impossible to do by hand. The key or the clue here is that that's a 0.5 or a half of an angle at the end. So this might be half of a special angle. If you were to double that angle, you would see that's 315 degrees over 2. And grab a calculator, I promise you that's 315 degrees over 2, and the special angle related to 315 degrees is 45 degrees. So if you were to look at 315 degrees, that would land you in the fourth quadrant. That's 315 degrees, and you'd have a reference angle of 45 degrees. That's a special angle. So that's a keeper. I want an angle here in the numerator that has a special reference angle. So let's see. Sine of the half angle is equal to plus or minus, and let me write that in blue like I did in the last example, because I know I'm going to replace that in a moment. The square root of 1 minus, remember the sine, you're going to do the opposite inside the half angle formula. So 1 minus the cosine of that 315 degree angle, and that is over 2 within the radical. Okay. Now, before I go any further, I just want to ask myself, where is it going to be plus or minus? That is, what quadrant does this angle right here reside in? Well, 157 degrees, that's quadrant 2, 157.5, it's quadrant 2. And I happen to know that in quadrant 2, sine is positive. So I'm going to keep the positive. I'm going to throw out the negative possible solution. That is gone. And so now I continue forward. Remember, trig is about reference angles and quadrants. I've just used a quadrant there. And I'll go ahead and just say this is equal to, we have the positive square root of 1 minus something over 2. The reference angle for 315 degrees, the reference angle, is 45 degrees. And by the way, 315 degrees is in quadrant 4. So I have the cosine in quadrant 4 and with reference angle of 45 degrees. Well, cosine in quadrant 4 is positive, and we're going to trade out that cosine of 315 for a cosine of 45. So I get to take away that large angle and replace it with the reference angle as long as I consider the quadrant there. And cleaning this up, that'll be the positive square root of 1 minus the cosine of 45 degrees. Again, that's all over 2. And this will be equal to the square root of 1 minus 1 over root 2. Again, all over 2. And I will multiply both numerator and denominator of the radicand by root 2. And again, I'm fine with my students leaving this problem like this. However, if your instructor requires you to rationalize denominators, this will rationalize down to the square root of 2 minus root 2 over 2. Not that my students have to do it, but your instructor might force you to do it. So there you go. So that's another good example. Every single time you do one of these problems, you do have to consider about that quadrant. Is it plus or minus? You have to take care of the plus or minus in the half angle formula. Look at the quadrant of the angle for the original problem. All right, so that finishes it out for this video. And then we're going to do more problems in the next video. It's just that this one is evaluating just simple, like, hey, what's the cosine of this angle? Or what's the sine of this angle? But in the next video, we'll expand upon that.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles. Get affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.